Prompt engineering sounds like it belongs in a machine learning research lab. It does not. It is a practical, learnable skill that any QA engineer can develop, and right now it is probably the highest leverage skill you can build if you want to use AI tools effectively in your daily work. The difference between a mediocre AI output and a genuinely useful one is almost always the quality of the prompt. Not the model. Not the specific tool. The prompt. QA engineers who learn to write good prompts consistently get better test cases, better bug reports, better coverage analysis, and better answers to complex questions about their systems. The ones who write vague or incomplete prompts get vague and incomplete responses, spend time fixing bad output, and eventually conclude that AI tools are not useful. That conclusion is understandable but wrong. The tool is not the problem. The prompt is. In this episode, we are going to make the skill of prompt engineering concrete and practical. We will cover the 3-element framework that underlies every good prompt, 5 specific prompt patterns that are particularly valuable in a QA context, and 2 advanced techniques that experienced AI users apply to get consistently better results. By the end of this episode, you will have a framework you can apply immediately to every AI interaction in your QA workflow. Let's get into it. Every effective prompt has 3 core elements: context, instruction, and format. Context tells the model what it needs to know to answer well. Instruction tells it exactly what you want it to do. Format tells it how to structure the output so it is immediately usable. Most bad prompts are missing one or more of these elements. Consider this prompt: write test cases for the login feature. That prompt has an instruction but no context and no format. The model does not know what kind of application this is, what authentication methods are supported, what the edge cases are, or how you want the output structured. It will give you something generic. Now compare that to this: you are a senior QA engineer on a B2B SaaS platform. The login feature accepts an email and password, supports single sign-on via SAML for enterprise customers, and enforces a 5-attempt lockout policy with a 15-minute cooldown. Generate test cases in this format: test ID, title, preconditions, steps, expected result. Cover functional testing, security scenarios, and edge cases related to the SSO flow and the lockout policy. That prompt has all 3 elements. The context describes the system, the user type, and the key features. The instruction is specific about what you want. The format is explicit. The output from that prompt is dramatically more useful and immediately actionable than the output from the vague version. The skill of prompt engineering is largely the skill of asking yourself, before you send anything, what information would a new QA engineer need to do this task well? Then putting that information in the prompt. There are 5 prompt patterns that are particularly valuable in a QA context. The first is the role pattern. Begin your prompt by assigning the model a specific role. You are a senior QA engineer with expertise in API testing and security. This primes the model to respond with the depth, vocabulary, and focus of that role, which consistently improves output quality on technical tasks. The second is the constraint pattern. After stating what you want, explicitly state what you do not want. Do not include basic happy path tests because I already have those covered. Focus exclusively on negative scenarios, boundary conditions, and security edge cases. Constraints prevent the model from filling your response with obvious content you do not need. The third is the example pattern. If you have a specific output format your team uses, paste in 1 or 2 examples before asking for the full output. The model will match the format precisely, which saves reformatting time. The fourth is the chain of thought pattern. For complex features with many interacting components, ask the model to reason through the problem before generating the output. First, identify all the ways this feature could fail or be misused. Then generate a test case for each failure mode you identified. The intermediate reasoning step dramatically improves output quality on complex tasks. The fifth is the critique pattern. After generating a set of test cases, ask the model to review them and identify gaps. The model is often better at finding gaps in existing output than generating complete output from scratch in a single pass. Let me show the practical difference between a weak prompt and a strong one using a real QA task. The task is generating test cases for a file upload feature. Here is the weak prompt: write test cases for the file upload feature. Here is the strong prompt: you are a senior QA engineer. The file upload feature allows authenticated users to upload CSV files up to 10 megabytes. The system validates the file type using MIME type detection and file extension, validates the file size, and parses the CSV structure to verify required columns are present. Invalid files are rejected immediately with a specific error message describing what is wrong. Valid files are queued for asynchronous processing and the user sees a pending status until processing is complete. Do not include test cases for the downstream processing pipeline or the email notification, because those are covered in separate test suites. Generate test cases in this format: ID, title, preconditions, steps, expected result. Cover file type validation failures, size boundary conditions, CSV structure validation, concurrent uploads from the same user, and behavior when the upload service is unavailable. Before generating the test cases, list the categories of tests you plan to cover. The strong prompt produces specific and actionable test cases for MIME type spoofing, size at exactly 10 megabytes and 1 byte above, malformed CSV headers, concurrent upload behavior, and graceful degradation when the service is down. The weak prompt produces 5 generic test cases applicable to any file upload anywhere. The difference is entirely in the context and the constraints. Both prompts take approximately the same amount of time to write. The strong one simply requires more deliberate thinking before you type. 2 advanced techniques that are worth building into your permanent workflow. The first is maintaining a prompt template library. Once you have a prompt structure that consistently produces high-quality output for a specific task, save it as a reusable template. Replace the parts that change each time with clearly labeled placeholders. Feature description goes here. Acceptance criteria go here. Known constraints go here. When you need the template, fill in the placeholders and run it. Over time, you build a library of proven prompts for your most common QA tasks: test case generation from user stories, bug report drafting from raw observations, coverage gap analysis from a test suite, risk assessment from a feature description. Engineers who maintain a prompt library are significantly faster than those who write prompts from scratch every time, and their output is more consistent because the prompt structure itself has been proven to work. The second advanced technique is prompt chaining. Some tasks are too complex or too long to handle well in a single prompt. Break them into sequential stages. The first prompt generates a structured list of test scenarios from the requirements. The second prompt takes the list as input and generates detailed test cases for each scenario. The third prompt takes the full test suite as input and performs a gap analysis. Each stage is focused on one thing, the output of each stage is easy to review and correct, and the final result is significantly more thorough than anything you would get from a single pass. This approach is particularly powerful for large features with many interacting behaviors. Prompt engineering is not a mysterious or advanced skill reserved for people who understand how language models work internally. It is a learnable craft built on 3 simple principles. Give the model the context it needs to do the task well. Be specific and explicit about what you want. Specify the format so the output is immediately usable. Then add constraints to eliminate obvious content, examples to guide the format, chain of thought steps for complex tasks, and critique passes to find gaps. Build a library of templates for your most common tasks, and use prompt chaining when a single prompt is not enough. These are practical habits, not theoretical concepts. Each one has an immediate and measurable impact on the quality of what you get back. The engineers who develop these habits early are going to use AI tools more effectively than those who do not, and that gap is going to widen as the tools themselves improve and become more capable. In the next episode, we are shifting to a specific and high-value use case, using AI tools for bug reporting and root cause analysis. Writing a bug report that actually gets fixed is a skill in itself. A well-structured report with clear reproduction steps gets prioritized and resolved faster than a vague one. AI can help you produce that quality of report consistently, even at the end of a long testing day. Subscribe so you do not miss it.